So this is a talk about composing music by writing code in a way that utilizes functional programming techniques. Composing music by writing code is something that's always interested me, to the point that in 2012 I started to sketch out some ideas for a new programming language whose exact purpose was to compose music. So just a little bit about me. This is my website, my Twitter handle. It's kind of looted. I'm from the U.S. I live in a little town called Hillsborough, North Carolina, and work 20 minutes away by car in Durham, North Carolina, at a company called Adzerk. And this is just a quick little one sheet about Adzerk. I'm not going to read it, but in a nutshell, we're an ad-serving platform designed by developers for developers. So if you should consider Adzerk if you ever find yourself in a place where you need to, or you'd like to create your own ad server, more, from scratch, but without actually doing all the work yourself. So Adzerk can do all the heavy lifting there. And we use a lot of Clojure there. I'm on the UI and API team. We have a complex UI where the front end is Clojure script, back end is Clojure, and we maintain a bunch of back end services that are also written in Clojure. So we're a lot of Clojure enthusiasts there. We like Lisp and functional programming and good stuff like that. Right, so enough about ads, more about Alda. This is me in 2005. Can anybody name the musical instrument that I'm playing in this picture? Yeah, all right. You wouldn't believe how many people don't know what this is. Yeah, so I studied bassoon performance and music composition in college. That was at the University of North Carolina, Chapel Hill. And I was more interested in music composition. Still fascinates me, this idea that you can have any type of music or sound in your head, and composition is the process of getting that out of your head and out into the world. And the challenge is how do you notate it in a way that can be realized. So, ever since I studied composition, I've just been thinking more and more about what is the ideal means for notation. And so one realization I had is that there's a very profound effect from your medium of notation. It has a very profound effect on the music that you can create. In particular, I was doing a lot of thinking about these graphical sheet music editing programs, like the one that I used, which is called Sibelius. This is a screenshot. So I'm not going to knock Sibelius. It's actually wonderful. It's an industry standard that music composition students and composers use. It's very feature-rich. There's a lot of stuff you can do with it. But I was always sort of vaguely dissatisfied with it. And one of my composition professors said something that really resonated with me, which is that you should really you should use caution when using software like this to compose, because if you lean on it too much, you end up getting away from the creative aspect of music, and you're sort of focusing too much on just the act of notation. In particular, there's sort of a tendency to get stuck in this this sort of inefficient feedback loop where you're just dragging notes around on the screen and hitting play and seeing what that sounds like. And then, okay, let me try drag this note a little bit, so, up a little bit, and I'll go drag a sharp over onto it and see what that sounds like. And we like feedback loops as programmers, but only when the feedback is fast and you can really fly and and be able to work efficiently that way. So I've always thought the best way to compose is to sit down at a piano or pick up a guitar or whatever your instrument of choice is, and compose organically that way. Like you play music until you arrive upon some musical idea or phrase that you like, and then you go and notate it later. But then after college, I got more into programming and learned about stuff like the Unix philosophy and developing software at the command line. And I just got really attached to that style of creation. And I started to wonder about how you might be able to extend that idea to creating music. Like, what if I could hack on a music composition in the same way that I hack on personal software projects? So eventually, out of that idea, Alda was born. So Alda is a music composition programming language. It allows you to express a musical score as a text document, and you can use a command line client to play it back. There's integration with various text editors, I'm the author of the Vim plugin for it. There's also an Emacs plugin and various other plugins. This talk will be, I'm going to switch to my editor pretty soon here and just focus on demoing this for you. And I'm going to kind of fly through a lot of the basics because while I hope it's interesting, it's not particularly relevant to functional programming, so I really want to focus on that aspect of how I compose with Alda. I have one more slide. This is a very technical architectural diagram of Alda, the language, and it's sort of how it's laid out, the layers of the language. So on top, you have a sort of a markup style. I've used HTML as an example, but it's not at all XML based or anything like that, so don't run away from it. But I like HTML as an analogy there because it's approachable for beginners. Markup is like what you see is what you get. Every HTML element is what it is. You can write it, and then you can open your browser and you see where that element is in the DOM. And similarly, in Alda, the markup elements are like things like notes and chords and rests and instrument parts. And I designed it specifically for beginners who might have no experience at all with programming, and they want to get their toes wet. So there's that layer. But then if you dive below the surface, there's this extra rich, creamy layer of functional goodness that is Lisp and functional programming. And this is Clojure as an example, but it actually is Clojure. You can write Clojure code inline in your Alda score, and each S expression can represent an element that you might also express as markup if you preferred. And these things are interchangeable. You can choose where you want to use the markup style and where you want to dip below and start writing code. So that's all I've got for slides. Let's see how I'm doing on time. All right, great. About halfway through. All right. So, like I said, I'm just going to fly through these. Hopefully, if I do this right, I'll have a little bit of time at the end. So if anybody has any questions about like particular bits of syntax, like what does this mean? What does this bit of syntax mean? Happy to answer those then. So this is sort of like a hello world to C major scale played on a glockenspiel. And this is an exploration of note lengths. They're sticky in Alda. So when you express that a note is a 16th note, this is a C 16th note, every note following that will then be a 16th note until you change it again. Moving on. Chords are just notes played at the same time, and the syntax in Alda is slashes between the notes. You can also go up and down octaves, so you can build your chord up from the bottom. And voices, the idea here is that you have a single instrument, but it's playing multiple melodies or musical ideas at the same time. Think of a piano player with two hands. With one hand, you can play a melody over the top, and then with the other hand, you can play chords to support it underneath. So this first line was just a melody, and then below that. So that's voices. And of course, you can also have multiple instruments playing all at the same time. There's also support for variables, which are somewhat interesting, maybe not so much for us functional programming enthusiasts. But one thing that is kind of interesting that is crucial when we're writing code in a functional way is this idea of building things up from parts that are immutable and then giving them names, adding named things together and giving those names. So this is sort of a way of making a kind of Philip Glass style thing. All right, so we've arrived at the part that I've been flying through the slides to get through. This is a basic illustration of how the two styles are compatible. So this line here and then this S expression sound the same, and in fact are the same from a data standpoint. So each syntactic element can also be derived or represented as a call to this a function from this musical DSL that we've written into Alda. So like the piano kind of gives you a scope where everything following it is within that instrument part. And then it has a couple things, an octave set event, which sets the octave to 4, and then a chord event, which contains 4 notes and an octave up. So from there, basically everything between parentheses is being just evaled, parsed and evaled as closure code within this environment that has this DSL set up. So we can start to use the Closure Standard library, which is really good at taking data and then just transforming it using functional programming techniques that we know and love. You have stuff like map and a variety of even richer standard library core functions. So here we have a call to a note function, which takes a pitch and a duration. In this case, it's C and an 8th note, and makes it a note. Hang on. 8th note. So that we can then we can take this little bit of code and stick it inside of an anonymous function that takes a letter. So now instead of C, it could be whatever letter we've passed into the function, and we can map that over this vector of keywords. So we get the 8th notes, C, E, G, A, D, B. So this is a really useful function, so we can extract that to the top level, give it a name, 8th note, and then we can call it sort of like this. Oh, hang on. There we go. This is, if you remember from Joe's talk earlier, the pipe operator in Elixir, this is sort of the closure's equivalent of that. It's a threading macro. So I really like it. It's one of my favorite things about programming in Clojure, because you can express things going sort of in order of what you do to them from the inside out, but in a way that's easier to read. So we start with the same vector of keywords, C, E, G, A, D, B, and we cycle it forever. So this returns an infinite lazy sequence. That is, these values repeated forever. C, E, G, A, D, B, on and on, ad infinitum. And then we can map, will sometimes, depending on the value you pass it, will also return a lazy sequence. So now this is a lazy sequence of 8th notes with those notes. And then we can make it finite. We can just take the first 16. So this isn't particularly interesting from a functional perspective or programming perspective. I'm just setting up the next example. But modes can be, there's an Alda standard function key signature, which takes a specification like this, and it will sort of set your flats and sharps automatically for you. It's my shot at a layman's explanation of modes or scales. So on every other line here, I've got the notes C, D, E, F, G. But they, in practice, they end up becoming, for example, this E is going to be an E flat because that's what it is in this scale or mode. So you can kind of hear how the notes change every time I change the key signature. Does that make sense? So now I can take that idea, or this key signature function, wrap it in an anonymous function that will randomly select a mode from this list, and then I can there's this really great Clojure core function repeatedly, which takes a function and returns the result of calling that function, presumably one that has side effects, so that or maybe not side effects, but it's not pure. It's going to return a different value every time. In this case, it's randomly going to be a different mode every time. And it returns an infinite lazy sequence of those values. So now we have an infinite lazy sequence of random modes. And I'm not going to go through every line of this, but basically you can take things like that. You can interleave those random modes into these lists of notes and arrive upon something like the world's worst bebop synth solo. It's just sort of like twiddling all over the place, and every now and then you change the modes. Just like an expert jazz keyboardist. All right, so this is on a more serious note. This is a piece of music that I composed using Alda. I really enjoy elements of randomness in music because the piece is different every time you listen to it, and oftentimes, almost always, I find there's something in there that ends up these little happy accidents that sound really interesting, almost like a human could have come up with that idea. So I like to do that and just kind of listen to it and then pick out these little ideas and write them down and then use those ideas later. So the bulk of the work in this score is contained in this function, random note. It will return, each time you call it, it'll either return a note or a rest that has a random duration, and the note will have a random pitch. And then I just declare 3 instruments, an electric piano, timpani, and a celeste, and pan them differently in the stereo spectrum. And each instrument part has 20 random notes, and this is kind of what that sounds like. Sort of ominous. What does it mean? Great comment. How am I doing on time? Oh, really? Oh, all right. All right, well, I have one more example, and then I can take questions. This is a little more fun. Briefly, the way the percussion works in Alda is it follows the MIDI spec, where every note on a keyboard is a different percussion sound. So it just so happens that in the 4th octave, these notes C through E are bongo sounds. A bit quiet. Oh, there we go. Long story short, I wrote a function that generates random bongo patterns. It's amazing, just by using randomness, like each hit has a different velocity, a different, like it's sort of being hit harder or softer, and is a different drum being hit, and it just so happens that sounds quite human. It's very interesting. So that's all I've got. I'll take questions.
So I was just wondering a bit about prior sort of art, like what you've been inspired by, in particular if you've seen Extempore, which is another Lisp-based thing. It's got some really interesting ideas in it.
Yeah, so there are actually a lot of music or audio programming languages. If you just go to Wikipedia and search for that, audio programming languages, there's this enormous list. And I mean, that's initially where I went when I was looking for a way to compose music in a more programming way, in a command line environment. And they're all different. They all have different objectives. I couldn't find one that was beginner friendly, that had a very simple sort of markup like syntax, and B was expressive enough and had enough features to do everything that I wanted to do with it. But in particular, I've been really inspired by MML, music macro language. Which was used in a lot of video games in the 80s and 90s, I think. As well as LilyPond is a really great language that's specifically for music notation. It outputs beautifully engraved sheet music, and the language is really well designed. I stole a lot of ideas from LilyPond.
And I guess, so the other part was Extempore.
Oh, yeah. Yeah, so Lisp, I'm sure there's a rich history of Lisps being used for music programming languages. I've seen a couple of them. And I watched Andrew Sorensen, who was the guy behind Extempore, has given some really good talks about that. I watched the one from last year at this conference. And yeah, it's really cool. There's also a Clojure one called Overtone, which is kind of a similar idea. I think it's built on top of SuperCollider, a type of synthesizer. Software synthesizer that has its own sort of low-level programming language built in. Those are really great too. One key thing is that a lot of those languages like Extempore and Overtone and Title is a good Haskell-based one, are oriented towards live coding. And that's something that is really interesting. I've always loved watching live coding music sessions, but I think it's a sort of a different objective for a language to try to support that. Alda's focus has always been not live coding, but composition.
My dad worked on the Fairlight CMI, which was the first digital sampler. It was an Australian invention, and so he worked on that from the early 80s and did a hell of a lot of stuff. So I got a lot of questions, so I better give this to other people.
Awesome.
Just curious, could you generate sheet music from this and then give it to musicians?
Not yet, unfortunately. It's something I really want to do. We're very close to be able to export a MIDI file from an Alda score. So from there, it should be just hop, skip, and a jump to generating sheet music.
Hey, thanks, that's super cool. I was just wondering if you've hooked it up dynamically to weird things happening on your computer or when you receive messages or anything like that.
Oh, that's an interesting idea. Yeah, like the Alda runtime, you're just you have access to anything you could write closure for. All sorts. You could use all sorts of side effects, not just generating random numbers, but any sort of I/O. You can hook into system events or something and have that generate music. I've always wanted to experiment with that, or like calling out to some sort of weather API or something and then generating music from that. It's a really interesting idea.
More of an API design question. I was wondering, like your API looks kind of imperative in the sense that you set the octave or you set the note length.
Yep.
Is that to make it map more easily from your markup layer, or is it? I was wondering if you'd thought about having setting the note duration being a thing that applies to all notes passed as an argument, because then you could do speed up, slow downs really quite easily.
Yeah, so it's sort of a concession to the markup style, like you're hinting at. I think so. There's that was a difficult design choice for me to make, because there's on a note, if you're modeling a note, there's various features of the note. There's the pitch, the duration, and there's a third thing that I'm not quite remember. Oh, the octave is part of it. Yeah, so it's not just the pitch; it's the sort of the letter of the note and the accidentals and the note length. And so it's hard to come up with a really concise syntax for that that I found satisfying enough. So in my experience, I found that I was changing the note length less. I was often just changing it every now and then doing a run of 8th notes or a run of 16th notes. So I don't know. I just kind of like the conciseness of that, doing it that way. And then I kind of tacked on a functional style later. If that makes sense. But if you're working with the closure style, you can really you can define your own helper functions and do things however you'd like, and define your own algorithms about how to change it. So it's very flexible that way.
Hi, so yeah, as you just mentioned there, you've got sort of two styles here. You've got the very S expression, Lisp sort of based one, and then you've got the kind of, C8, C+ kind of style at the top of the current buffer. I'm wondering, how do you translate between one of them and the other? Are you using some kind of parsing technology, and what is that?
So originally, I was actually going from one to the other. The parser would take the markup syntax and transform it into the Lisp S expression and then evaluate it. But then as a performance improvement, we just made the parser just emits the data directly. So it's like you have the one thing and the other, and they return the same thing. I was manually doing the translation.
Hey, so I think early on in the talk you said that you had a professor who kind of warned you about using a GUI tool and how it might influence your composing. Mm-hmm. Have you found that working on Alda and working this way has then changed the way you compose music, or I guess changed the output, the compositions that you now produce?
Yeah, absolutely. I sort of approach music differently, because it's it's easier to do certain things when working this way. Like you start to think about music as taking, like you define some sort of data, and then you map a function over it, or define some algorithm and kind of run it over the data over and over again. Or you work that way instead of coming up with motifs, like the traditional way, which is like coming up with motifs and thinking really hard about how to put them together. And it's all sort of a manual process that way. So, I haven't really composed traditional Western music this way. To be honest, I'm still kind of thinking about whether that's the right way to do that. I have done I've transcribed a Bach cello suite in Alda and had a pretty good time with it. But it's just a totally different way of doing it, because you're sitting there, like I actually took out some sheet music and I was like, all right, that's a C, so type C, that's a C sharp. So it's, just a different way of working.
On that note, so have you used maybe sort of data input? So one of the things that Dad did was a scientific experiment taking DNA sequences and to try and see if the ear would be able to pick out patterns in these things to try and do sequencing of them. And scientifically, it was complete failure, but musically, it was fantastic. He made some amazing pieces with it. So, have you thought about doing that kind of thing, taking sources of data and using them as inputs, because they're real world and they have that kind of randomness, but they're deterministic in terms, you've recorded them already.
So what sort of data sets would they use?
Well, in this case, it was DNA, so actual nucleotides and proteins and all of that. So, yeah.
Yeah, I really like that idea. I haven't done anything like that myself, but yeah, it'd be really cool to, or like take dump some binary file or something and like using the contents to generate music or something like that. Yeah, I've always thought that was interesting to take like data that's not related, it wasn't like calculated at all to be music, and just listening to it and seeing if you can find some music in it.
So I think other ones have been like things from radio telescopes and there's lots of amazing sources of data like that.
Yeah.
Maybe Dick.
Yeah, yeah, coming full circle.
So earlier today we saw a talk on like generative art. Are you aware of any like techniques you can use for generative music in a similar way?
Like not necessarily with Alda, but other things.
Or just in general, like techniques or algorithms, anything like that, and have you applied them in Alda?
Yeah, I think it's sort of like a trial and error kind of thing. Like you just you come up with a basic idea. Like let me look through my photos folder and like start dumping the data from images, just like the binary data, and just like take a sampling of that and see if any of it looks interesting or seems interesting. Like maybe something in the headers is interesting. And you do that until you find something interesting, and then you kind of like focus your efforts on that and try it with other images or that part of the file or whatever. It's all sort of, I guess like any art, it's just like trial and error. There's a question up there.
Somebody else asked.
Have you got a ClojureScript demo for us today?
No, so that's a really interesting question, because I've thought about how to get Alda from its current implementation. It's a JVM Clojure program into the browser in some way, and there's ways you can do that. Like with Clojure and ClojureScript, the API of the two languages is very similar, and oftentimes you can use the same code and it'll just work. You just have to replace the bits that call into Java with bits that call into JavaScript. So at some point, I do have an idea to go through and try to do that and make like a portable like JavaScript export to JavaScript version of Alda, like run in the browser. It's going to be a while before I can get to that though.
Well, thank you, Dave.
Thank you.